Hello, my name is Adam. We will try to implement a CRUD-like application predominantly by prompting an LLM. So we will use the Cursor IDE for our work, and we will see how far the prompting will actually get us. So CRUD applications aren't usually the most exciting ones to develop. They're actually quite boring, so I guess they're the perfect candidate to automate and to write them using a large language model. So we are going to use a stack that's maybe not typical, for startups, but rather more often encountered in scale-ups, in medium and large organizations. So we are going to use the JVM on the backend and React and TypeScript on the front end. So we will actually have two applications which will talk to each other. So that's also, I guess, quite a typical architecture in such scenarios and in such organizations. So for the JVM, we are going to use Java 21 with virtual threads. So this actually gives us a pretty straightforward code. So we can code using direct style, we can code using blocking code. So the LLM should be able to comprehend this quite easily. Virtual threads also give us a great performance, so known from like reactive frameworks. So we are going to use that. We will use the Scala programming language and a couple of libraries associated there. On the front end, we stick with TypeScript, which is like, I guess, the most popular choice nowadays, and React for implementing web interfaces. So we won't actually start from scratch. Instead, what we will do is we will use a Bootzooka template. So Bootzooka is our opinionated application template, which is the starting point of developing microservices or simple web applications. So it has some basic functionality written, like login, registration, forgot password. It's not that it's there to necessarily use it. You might throw it away or just replace it with some other implementation. It's more to provide a basic structure of how the code is organized, right? So we have some feature packages, we have some layers like API layers, service layers, we have the builds set up both for the backend, for the front end. We also have a way of generating API documentation. So on the backend, we use the Tapir library using, it's a Scala library which lets you describe endpoints, and from using code, then from these endpoints, open API documentation is generated. And actually, to ensure full synchronization between the backend and the front end, on the front-end side, there's an automatic process which picks up any changes in this specification, which is written when the backend is compiled. So on the front-end, we take the OpenAPI spec and we automatically generate service code to actually use the backend services. So this is all nicely synchronized using the OpenAPI specification that's generated from code. So code becomes the single source of truth. So we will use this template. I will go through a couple of characteristic things about Bootzooka, about the libraries that we have chosen. Of course, in a real application, you would probably swap out some of the choices that we have made. Here we will just go with what's included. So I will start by cloning this into our repository, into our terminal over here, and I will rename this application from Bootzooka, which is like the application, the template name, to our application name, which will be Avocado. And inside of Avocado, I will also use a built-in command which is over here, which is like a section how to actually use the template. So we will rename the project so that any occurrences of Bootzooka are actually replaced with our application name. Software will be the package still, and Avocado is the project name. Okay, so let's actually rename that. And it will just take some time to actually, on the first use, we have to compile the entire backend. And so this terminal will be used for running the backend and for monitoring the changes. So this looks like it's done. Okay, we can now start the backend and see if the backend works. We can also open up cursor with the project. So it will also need to be imported. So we are using cursor with Scala Metals. Scala Metals is a VS Code cursor plugin which provides, Scala functionality and integrates with Scala builds. So we need to import the build so that we get code completion. We also have an MCP server, so we can just verify that it works correctly. Oh, it's disabled, so we know to enable it. So we've got an MCP server that's provided by Metals, which allows the LLMs to use tools such as compilation, such as looking for symbols, such as looking for usages, without resorting to using the console, which is like the default mode, right? So this actually is a more reliable way to compile files, for example, and the LLMs actually quite often use this MCP. We will probably also see that later. Okay, so we've got the project imported. One thing we need to do over here that's also documented in the README is that we need to create an env file. So we will actually copy the example over here, and the env file tells the front end where the backend is located, right? So the backend is going to be started on port 8080 and the front end on port 8081, if I recall correctly. Okay, so we've got the backend started. It's automatically looking for changes in source files. And if there's any changes, it will actually restart the backend, so we can go and see that the documentation is there, right? So we can hit some API endpoints. So these are all that are provided, like user registration, logging, change password, and password forget. So not much, but it gives you the basic structure of the project, and hopefully LLM will follow it. Okay, and then we have the front end, which we start with a dedicated script. So it needs to generate, to download all the dependencies, and you can see that we are greeted like with the login screen. Everything is customized with our application name. So as I mentioned, like this is the backend and frontend are synchronized using the OpenAPI file. So if we go, I stopped the. So let's start the backend as well. I must have stopped it accidentally. So when the backend is actually built, the OpenAPI file is written somewhere here. The OpenAPI description is written to a YAML file, which is then picked up by the front-end build, and the service files to call the backend actually automatically generated. If any of these files changes, it's all reloaded automatically as long as these scripts are running. So we've got the front-end running. One important thing is I do have a database created in Postgres. So I have a locally running Postgres, and you can see that there are some tables created by the backend. So this will be used. So yeah, so we can like register a new user. So like Adam. Okay, we create a new account. We have logged in. Great. You can see that I'm logged in here, and there's been some interactions on the backend, right? So you can see that it's sending me a welcome email, which is like a dummy implementation, but like there has been some interaction between the backend and the frontend. Okay, so now let's go to the implementation. We will actually start by creating a plan. So I don't want to, jump right into coding. I want to first create an implementation plan so that we are sure that we're on the same page with the LLM on what we want to implement. So I will describe the feature and create like an implementation plan. So no code yet. So just storing the steps in a file so that we can review and maybe amend it later. So okay, let's start by creating an implementation plan for a fridge management feature. I want the feature to be kept very simple. The user should be able. should be able to add items which they bought with the items name and expiration date, and later retrieve either all items, expired items, or expiring soon. So the plan should be written to a fridge.txt file, and it shouldn't contain any code, just the specification, the API endpoints to create, and the development plan. Keep the plan succinct and short, don't add any new features. Okay, let's see where this gets us. So from past experience, the LLMs sometimes tend to overcomplicate stuff and add extra things. I will actually probably edit the video, because the LLMs sometimes think for a long time and iterate on the code, so that's probably not that interesting. So I will probably cut these things out so that you're not surprised. Okay, so let's see what's the plan here. Fridge specification: a simple fridge management system that allows users to track food items and the expiration dates. Add food items, retrieve, okay, the data model looks fine, it's associated with the user. So we've got an endpoint to add a new food item with a name and an expiration date. It returns the item ID, get all items, and get expiring items. Okay, so some amendments. The user should also be able to delete items from the fridge. Let's create a single item listing endpoint with an optional expiration filter. So we don't actually need 3 endpoints, right? For that, we can make it more general and just use the UI to provide the right parameters. So the implementation: create fridge item model. Okay, so for the implementation, I would actually prefer to go with a top-down approach. So first, writing the API layer with a mock service, then integration tests for that, and only later proceeding with the service and model. So that's not like full TDD, but maybe a bit more. Also, I want to create the API first, so that I'm sure that it's the shapes, the LLM actually gets this part right, and only later we can fill in what's needed in the database changes and so on. Okay, let's restructure the implementation plan so that it has numbered steps, so that we can refer to those steps later. Okay, also the endpoints we need front-end implementation at the end. Okay, so let's see how the plan. So actually the plan needs to be restructured quite a lot, so we can see that it's good that we started with actually the plan and not the implementation right away. Okay, so we've got the updated plan. So we've got these 3 items: adding, retrieving, and deleting. Maybe, okay, fridge item ID, user ID, that's fine. Add a new food item. We can filter all expiring soon. Okay, well, that's a good start maybe. And list fridge items, delete a specific item. So now the development plan. First the API layer. So okay, So this looks good. Integration testing, okay. Then the service model implementation, okay. Database implementation, backend testing. Okay, we already have. So I don't think we need that. Well, once we implement the database, of course we run the test, so that's not really needed. So let's just name it to 5. And yeah, generate API client. So this happens automatically create fridge components. Okay, so for the front end, the API client is generated automatically. Also include item quantity and a way to update items, because that's, you know, if you have like 10 eggs, maybe then you eat 2, so that's probably a common use case, so we'll include it right away. So otherwise I guess it looks good, so let's just update our plan over here. Okay, so now we have like a complete CRUD implementation plan, because we've got create, we've got read, we've got update and delete, so great. That's like a complete CRUD feature. So this looks good, and the front-end implementation properly numbered now. Okay, so we accept this file. So let's actually start. Let's start development by creating a branch and committing the plan. So let's just make sure that our plan is safe on a separate branch. We are lazy. We also use LLM to, you know, interact with Git and generate the commit messages for us. So that's maybe stretching it too far, but it worked. So okay. And maybe not the best allocation of resources, but would like to proceed with the first step. Yes, please. Okay, so let's create the API layer and let's see what the LLM comes up with. So maybe that's a good occasion to actually do a brief overview while the LLM is working of how the backend is structured. So we've got those packages which contain these features, as I've hinted before. So here, for example, we've got the API layer. So the API layer is split into 2 parts. So we are using the Tapir library. The Tapir library allows you to describe endpoints using Scala code along with their metadata. So here we've got like pure data, pure descriptions of the endpoints. These are contained in an object, so it's like a global thing. That can be used to generate the OpenAPI documentation without, you know, setting up the whole database connection, HTTP server stuff, and so on. So we've got those endpoints that are described over here. Each endpoint, you know, has some inputs, some outputs. It's all type safe in how the body and the parameters are parsed. So by convention, anything that comes over the network has the _in suffix, and if we send something over the network, it has the _out suffix. That's like the convention that's used in the template. The register in over here contains, you know, the data that's coming in from the user. We've got some automatically derived stuff here, so like JSON codecs, which allow us to parse and serialize to JSON. We've got schemas, JSON schemas, which are included in the documentation. Everything automatically generated in the compilation time. So that's the section where we describe the endpoints. That's like the static information. And then we've got the more dynamic part where we actually couple the endpoints with business logic. So we've got the endpoint, and we say that when the endpoint is invoked, we actually run a database transaction, and inside the transaction, we run our business logic method to register the new user, and then we return the result. In the service, so you can see that service is passed here as a parameter to the class. The service implementation then, you know, contains the actual logic checking if the user exists, if the formats are correct, and so on and so on. So like something you would expect from such a service. And this talks to the database, which just contains some SQL queries to actually write stuff to the database and read, maybe filter. So it uses the Magnum library, which provides all the basic CRUD repository implementations automatically on types. So here we have the user class, which is annotated with how it should be mapped to the database, right? Some fields have customized names, for example. So that's like the overall structure, and then we've got everything is wired up automatically in dependencies. So you can see some changes already done by the LLM. So the dependencies class is where all of these classes, the services, the models, the API are instantiated when the application starts up. The wiring is also done automatically using a library called macwire, also at compile time, so it doesn't have any, so at runtime we don't have to do any, you know, dependency discovery or anything like that. We just run generated code. So the startup time is quite nice. We do provide some dependencies that are created by hand, because, you know, maybe they have some configuration, they have like HTTP, so like infrastructural components, right? HTTP clients, maybe an email sender over here, the clock to use, open telemetry integration. So yeah, we provide all of that. So we can see that the LLM here, it's trying to generate our code. Yeah, it gets some feedback from the compiler. You can see the linter errors. So these are some compiler errors which the LLM then uses to actually improve the code. So yeah, it's rewrite. So I guess it went into some rabbit hole, because it's now writing fine again. But we will let it do its job and not be too bothered with it. Yeah, and then we have the main class where everything is started, right? So in the main class we create the dependencies. The dependencies class over here contains instances of the API, for example, and then we start the HTTP API. So that's quite easy to navigate. If you would like, you know, to understand where exactly things get instantiated, you can just do it using by navigating in the IDE. So that's quite straightforward to understand. Yeah, so the LLM is still thinking. It properly created, you know, like fridge feature package, and we can see the separation between the API and the service, same as in our user API. So this is all done correctly in terms of the overall very high level structure. Yeah, but maybe it will actually at some point finish generating. So we will let LLM work and come back when it's done. You can also see that it's actually using some tools here, right? So this compiled file, that's a tool provided by Scala Metals, an MCP tool, which is being used over here. So yeah, it's planning some steps, some completion challenges. It created a to-do list. So great, you know, it's a good approach to have a to-do list and just to fix issues one by one. Hopefully it will do that. Now it's adding files to Git for some reason, but we'll see how it goes. Okay, so the LLM needed some help when it comes to using the main imports mainly. So it just used a blanket import which imported some items twice. So we resolved all that. So now one thing I would like to fix is that the filtering over here. So instead of just having using the parse filter called from the business logic, I would actually prefer to use Tapir's mechanism where we can map over the query descriptions and provide a type safe way to provide already parsed inputs to the business logic, right? So some preliminary validation should already happen when this request is received. So I will ask the LLM actually to do that. Yeah, I will also ask it not to commit anything unless asked, right? Because that's what happened before. Maybe it got the wrong idea when we when we ask it to commit later. And yeah, so for the filter, I would like it to map over the query input and return a decode error. So that's kind of a Tapir thing that you need to know so you need to know the library a bit to actually implement this correctly. So yeah, let's ask the LLM to actually do that, and let's see where we get. Okay, so I think the LLM thinks that it's done, but we do have some compile errors over here. So this is removed. Okay, so that looks correct. We just get the filter, but the typing isn't yet correct. So we have it mapped over here both ways. So here we are parsing the query string, and here we are serializing it back. That's needed because the endpoint can be interpreted as a client or as a server. So that's correct. But now what's happening here? So an either, no, so that's not an expiration filter. Okay. So yeah, we should use eithers. Instead of eithers, use Tapir's decode result. Okay, so we generated some code. It used the context7 MCP tool to get the docs. It also used the Metals tool to compile everything. So this looks nice, right? We have everything validated over here and properly parsed. So that's good. We are using map decode over here. That's great. We have the imports correctly. Okay, so we've got this endpoint description part done correctly. We've got we have these endpoints coupled with business logic over here. So we are using an auth endpoint which actually runs the security to turn an API key into a user ID. So here we received a properly typed user ID. We also received the expiration filter, and I think earlier when the LLM was too eager to commit, it also committed some changes which actually added all these dependencies over here. Yeah, so you can see that the fridge API is over here, and it's already added to the dependency. So this should be actually already exposed. So we can see that the backend, it was reloading as the LLM was coding. There were some compilation errors, but now it started up properly, and the browser, you can see that the fridge is over. The fridge API endpoints are over here. Okay, awesome. So okay, so let's commit and proceed with the next step. So the next step is integration testing with step number 2, testing from the fridge.txt file. Okay, so for integration testing, the approach taken by Bootzooka is that well, generally for testing, the approach taken by Bootzooka is that we only or predominantly have integration tests. So each such a test we can take a look at, for example, the user API test over here. So what we have here is that we have kind of a high-level test where we send a request to register a user, and then we try to log in that user, and so on and so on. So we interact on the level of HTTP endpoints. So that's what the tests do. So they do use an embedded Postgres database. They do not start an HTTP server themselves, like an anti-HTTP server. Instead, what we do is we have this request class which manages and creates endpoints, which we then call. So what we do over here is we interpret, for example, the user endpoint. So once again, we use these endpoints, which are described as code, to generate a client call, and this client call is sent to a mock stub backend, and the stub backend it doesn't actually do any network communication. So instead what it does is it has all these endpoints registered with their business logic, and it checks if anything, if any of the endpoint matches, right? And if it does, it actually invokes it. So without the networking stuff, but this does include serializing all data to JSON and deserializing. So the encoding, decoding is also tested properly. So yeah, you can see that actually the LLM tries to create a test over here. Hopefully it will also, yeah, it read the request, so actually I hope it will get the right patterns. So we will leave LLM to work. Okay, so I guess the LLM is done. So it took like I guess 5 minutes or so, and a couple of iterations, you know, talking with the compiler and so on, but we finally have something to review. So yeah, let's look at the test. So there's like an unused import for a start, so let's just remove it, and another unused import over here. So I guess the LLMs aren't that great when cleaning up after themselves, but maybe you have to explicitly ask. Okay, it's using the local dates. No, I don't like this. We'll have to fix the local dates later. But we've got what? Add new food item, not add items with empty names, with invalid quantity. Okay, require authentication, so that's good. Return all items by default. So some warnings here. Okay, so we are only calling this for side effects, so we're going to use the discard method to actually discard the result, which is like a response probably. Yeah, response. So we are not, so we'll add an import over here, import aux discard, so that we can silence those warnings, and over here as well, same over here. Okay. And same over here, so there's just various tests for expiring items and all items for invalid. So this actually probably the filter here, which if it's invalid, this should be fridge API. So this will actually be rejected, right? Because we have an invalid filter, we return a decode result. So update the tests, so that if there's an invalid filter, you expect a 400 bad request. So that's one thing that we need to fix, and we need to discard things here as well. Isolate data between users, that's all good. Require authentication. Okay, so it's like superfluous probably, but okay, but maybe not. Not update with invalid data. Okay, that's a lot of tests, right? Okay, but that is fine. Okay, so this looks good. We'll just let the LLM update this single test. We should probably like review these tests more thoroughly, like in a real world application when you work on a business feature. But I trust that these tests, well, maybe trust is the wrong word. I hope that these tests test what they do, so we won't spend that much time in it. They look correct, right? But we didn't really do the required due diligence on them. But since it's a demo, I guess it will fly. So yeah, let's wait until we have everything generated. Okay, so I guess the LLM is close to being completed. Now it's calling testing to see if it works. Let's see if it updated the test. With filtering, right? Filter expired invalid. Oh, here it is. Yeah, so it properly updated the test. Hopefully it didn't break any of the other tests. Right, it used the MCP tool to run the test, and they are passing. Remember that we have like a mock implementation, in-memory implementation, so I guess it's correct. Okay, cool. So this looks good. Let's take a look at the requests file. So this looks good. So these are like the helper method to actually convert. To actually call our endpoints using the interpreted, using the client generated and interpreted based on the endpoint descriptions. So here there's some warnings, right? Oh, there was a warning here as well. Like, what's the warning over here? Unused import. So yeah, let's remove that. And there are some warnings here. So filter match may not be exhaustive. Okay, so get fridge items. Because if it's an invalid filter, we need to manually create the request, right? We cannot interpret, so the interpretation here forbids us to actually create an incorrect request, right? And here we need to create an incorrect one. So that's why the if over here, but that looks good. Okay, we'll fix the warning here, just adding a case, yeah. By throwing an exception so that we use the tests incorrectly. Okay, let's commit. Then I had one actually thing that I wanted to change in the fridge API. So what I didn't like here is that we are using local date. I would instead prefer to use instance which pinpoint a point in time exactly. Then update the API to always use instant, it's a class, instead of local date, and also rename fridge item response to fridge item out, which follows our convention, right? So this was like an oversight, but I noticed it when the tests were generated. Okay, so let's see how the LLMs does with that. Okay, I guess the LLM is close to being complete. Once again, it took like a couple of minutes, so we have to come up with some new work patterns, I guess, to structure our workflow properly, because if you give us bigger tasks to LLMs, it does take an untrivial amount of time. So not enough to context switch to another task, but also might not be that interesting to watch LLMs just generate code and more code. So there's the workflow somehow needs to improve. But yeah, so the tests, so it's calling testing, it's adding in to-do list, everything's done. Okay, so let's review. So we've got those instances over here. Now it's once again committing. No, I wanted to review, not commit. Oh man. Okay, well, we'll have to be very specific not to commit anything, or we'll just start a clean chat, I guess, for the next phase. Okay. Is now using modern timestamps, right? The LLMs try to justify their actions each time. Okay, so we've got this instance, we've got this renamed, and hopefully the tests are, I guess the tests are migrate. Yeah, tests are also updated, so we can take a look at the git diff over here. Yeah, the tests are also updated properly. Okay, cool. So now let's take a look at our plan. We are done with these 2 points. So let's tackle 3 and 4 at the same time, right? So I will actually stop the backend from recompiling, so that while the migration is developed, it doesn't try to apply the migration on the live database that we have for development. So I will start a new chat so that the context is clear, and maybe it will prevent the LLM from actually auto-committing into Git. Okay, so let's proceed with steps 3 and 4 from the plan. So that's a simple instruction, but we have the plan, so maybe it will surface. Let's see. So the LLM now tries to understand, once again, because we are starting with a clean context, what's the state of development so far, and hopefully using that it will be able, to actually implement the right thing. So I guess we will come back in like 5 minutes and see what happens. Okay, so the model, I guess, is done. So let's review the changes. Hopefully it won't commit anything so that we can actually review stuff. Okay, so let's go with reviewing the next file. Starting with the model. Maybe actually I would start with the migration, right? So we created a second migration over here. So the first migration, let's remind you, contained, you know, like user tables. That's what comes with the template, right? So yeah, we are following the pattern here. We're creating a migration for fridge items. We are using timestamps, very good. We have indexes on user ID and expiration. Actually, we should have a combined index on user ID. Okay, so yeah, let's just edit. I could ask the LM to do it, but that's a simple change. Yeah. So foreign key on users. Okay, so this looks correct now after this slight change, because you know we are only going to ever query the items for a given user ID, right? We don't want to cross-pollinate items across users. Okay, so that's fine. The model now. Okay, so we've got this item over here, which is mapped to the fridge items table, and these are like some macros which generate some CRUD operations on the database at compile time. And then what we have here, we have find all, find expired. So it's a query where the expiration date is expired, right, and is expiring soon. That's a threshold which is given as a parameter. Great. And why does it need the now actually? So yeah, so they are not expired yet. Yeah, so that's good. That's good. And we have the update item. We have the lead by D and find. Okay, so this looks correct as well. Now let's look at the fridge service. Okay, so it kept the mock fridge service and it retained the real fridge service. So I guess we don't need that, right? So let's just remove the mock fridge service and implement fridge service as a top level class without the trait. We don't need the trait actually now. Okay. Any more files? Yeah. So here. Once again, yeah, the fridge model. Okay, so let's wait for the model to actually fold these fridge service implementations into one thing. And meanwhile, we can start an SBT console here so that we can run the tests ourselves and just double check that everything is fine. So the test was the fridge API test, right? So now it should be using, now hopefully the test will use the real thing as well. So the backend here, and yeah, we'll call it once the generation is actually done. You can see it because I'm covering it. So let's maybe move myself. I will move myself over here. So now you can see the SBT output as well. Okay. So this says that it compiles successfully. So let's see, the fridge service uses the model add item. Okay. So what's the business logic here? The name is empty, so there's some validation. Otherwise, we create a new item. Yeah, this looks good. We insert it into the model. We are inside the transaction, so the transaction is started here at the API level, right? Because it's it's over here. So this is passed as a marker, as an implicit parameter that's needed by all database operations. This is like carries the connection. So we explicitly know that this method must be called within a transaction, and that's an important information for the user of the method, right? Okay, so this looks good. This looks good. This looks fine as well. Get items, okay, with the filter, and depending on the filter, we call the appropriate method here for 3 seconds or for 3 days. Okay, that looks good. Looks fine. Update item. Okay, now everything is not non-optional, so that looks suspicious. Update item. Item data name. So this should actually all be optional, right? Because we update things and we only might want to change unless we get everything back from the front end, right? The entire thing. So okay, that's maybe not ideal, but let's keep it that way. Find by user and ID. Okay, great. So everything everywhere is scoped by user ID. And delete item, we just forward to the deletion, and we return the mock model. Okay, so anything else to over here? We don't actually need to specify this, so that's superfluous, right? Because the auto wiring, if it doesn't find an explicitly given dependency, it will just use the default constructor, which is just fine. So we can remove this. And we remove the mock service, yes. This was needed before when we did trait, right? Because the dependence depended on the trait, and so we needed to provide explicitly the implementation. Now we only have the implementation, so that's easier. We actually probably will get some unused warnings here in a second. Okay, so let's run the tests meanwhile. And hopefully the tests will pass. In the fridge model there's something unused. Yeah. Okay. Okay, so we are running, we are using the embedded database. So let's see if that's actually, oh, 2 tests failed. That's something that the model that it should. Okay, so now we get a 404 instead when we not update item of another user. Right, so yeah, I guess a 404 is expected, right? Because we try to look up using our queries. We always, so in the model over here, we always pass in user ID, and we scope the query using the user ID. So if we try to get an item, right, find by ID and user, right, it will simply return 0 results. So yeah, we will update the tests so that it should be not found. It's also probably correct, not to expose the fact that an item with the given ID exists for another user. So this looks even better, I guess. So if we reviewed our tests properly, we would probably catch it earlier that it should be not found. Okay, okay, so let's commit. So this looks fine. It works well. So now we can actually proceed with the front end finally, right? That's the only thing that's left. So I will start the backend and it will probably run the update scripts, and it will provide the backend so that we can test the front end properly. So far we can interact with our application using the open API docs that have been generated. So if we go now to Postico, and probably when we refresh this, yeah, we have these fridge items over here. This is all started up, and yeah, we have committed everything, or we are in the process of committing stuff. Okay. Yes, I'm ready now. So now it's asking me if I want to commit. Yes, I want to commit, but I will start a clean chat once again so that it doesn't auto commit later, because it gets too eager if this happens. Okay, so because we have run the backend now, it has generated this open API description. And basing on this, you can see something I could not refresh. But I guess if we take a look at... okay, so it committed stuff. If we look at the UI and at the generated stuff, it should actually contain... Add item, does it have any fridge? Oh yeah, you can see that the TypeScript API already has the fridge items over here, so everything is nicely generated and synchronized with our OpenAPI plan. Anyway, so let's now go over here and let's, in a clean chat, let's proceed with step 5. And we will see if this will actually work or not. So, this is TypeScript, something that's very native to LLMs, so hopefully it will work fine. I'm wondering what are these errors, like what's... yeah, you can see that it was detecting changes to our OpenAPI file. So as we were iterating with the LLM on the description of the API, every time the API compiled, the description was written and the client side client calls, client services were regenerated. So I guess I'm not sure what the error is here. You could not fast refresh. Well, anyway. But I guess it did update what it should have updated. So yeah, okay, so we will once again leave the LLM to do its job and we will come back when it's actually done. Okay, so I think the LLM thinks that it's done, although there are some errors over here. See if it actually works, maybe. Okay, so we've got the fridge, okay. Item name, cheese. Expiration date tomorrow, add item. Okay, don't think it adds items to the fridge, so that's not good, right? Did it call the backend at least? Did call to get all the items, but it doesn't actually work. Yeah, cheese once again, maybe 8. Yeah, nothing happens. So, well, okay, so this looks good, right? Because it just adds the routes to the file. So, this doesn't look good because there are some errors over here. Validation schema, where's the handle submit and payload on success? No. Doesn't actually call. Okay, so it looks like there are some errors. Fix them, but more importantly, I can actually close this, we don't need this, right? More importantly, submitting doesn't call the backend. Use the generated API service classes to call the backend properly. Okay, so yeah, I will move myself back. Oh, sorry, I'll move myself back. And yeah, you are absolutely right. Of course, the user is always right. So that's one thing that the LLM has embedded. So let's leave the LLM once more to do the work and we'll come back soon. Okay, so the LLM thinks that it's done. I'm not so sure because there's some errors. Like, I'm not really very well versed in TypeScript, so I'm just exploring it as much as you do. And so let's see. Well, I did update things over here. Yeah, let's try cheese. And oh, okay. Now it worked for some reason. Okay, that's good. That's good. Eggs. Let's then we have 10 eggs and they expire on the 14th. Okay, fresh. And let's say we've got some bread which expires what's 27th tomorrow. Okay, expiring soon. Nice, nice. And let's say we've got some avocado which unfortunately expired 2 months ago. And we've got 12 of those. Expression like, cannot be. So we won't test it. Okay. So today, let's say today. Also in the past. Okay, expiring soon. No, not page not found. Because there's this fork on GitHub. Okay, so that's an unwanted interaction. Expired, no, expiring soon. Okay, so it seems it worked for some reason. Like we get some warnings from the editor, but it works. So we'll just accept all. So that's my mode of working on frontends. Okay, yeah. So I guess we are done, right? So this kind of works. Well, this works without kind of. I'm going to leave you with an exercise to the reader on why these errors are here. So I guess summing up, you know, it did take some time, right, to implement this whole thing. It wasn't completely trivial. I'm not sure if the LLM would manage to do it like in one shot without the plan and everything, but with our plan, I think we were quite confident that we are actually writing something that we want. So I guess this worked nicely. So still the LLM had some trouble. It needed to do a lot of iterations when writing the backend Scala code. But the MCP and the linter errors where the compiler output was very helpful, and it actually did manage to arrive. So there were kind of a couple of times where I had to backtrack and help maybe sometimes, but overall, like we implemented this way faster than I would type all of that code manually. Okay, so yeah, and for the frontend, I guess, you know, somebody knowing more about frontend, right? So I guess it's actually a good case study, right? Because I don't know much about frontends, so I'm not really able to tell if this code is right or wrong. I guess it's right, Because it probably follows the patterns set out by the other components. So yeah, I'm puzzled by the error because it works when it's run, but it just gives some compile errors, and the component is there, right? The fridge item list is there. So what's the problem? Yeah. Oh, anyway. Yeah, so I guess that will be all. We have our fridge management. I will go and eat the old bread. Well, thank you very much. Let's see if deleting works. Yes, it works. Okay, well, anyway, thank you very much. Hope you will enjoy. If you would have any questions, you know, post them beneath. If you would like to try out Bootzooka, here's the project. You can also leave a star. And if you'd like to see any more videos like this, where we try to work with the AI on some specific problem, let me know. And you know, user feedback is very valuable when it comes to picking on what kind of topics to work on next. So yeah, so please leave the feedback and let us know how you liked this video. Thank you very much.